Namaste. Myself KV Muralidhar Sharma, a research scholar in educational technology as applied to engineering thermodynamics at VTU Karnataka. I am deliberating on role of boundaries in thermodynamic systems. In the previous session, we have discussed about what is an engineering system and how it's classified under open, closed, and isolated systems. In continuation of that, let's understand the importance of the system boundary, a thermodynamic system boundary in this present class. The key concept we are dealing is all about the importance of the boundary in defining the system type. At the end of the session, the student has two takeaways. One, how a system boundary can be altered to transform an open system into a closed system, and the second takeaway is about identifying the importance of the boundary in specifying the system as open or closed system, the importance of the boundary. In dealing in the previous session, we didn't much talk about a system and the boundary and the surroundings, which are supposed to be the prerequisite. We adopted a three-stage approach, namely the stage one being identifying the different interactions, namely mass and energy including both work and mass, and identifying the connectivity or the correlation between the energy on one side and the type of the system on the other side, and the third, identifying based on this correlation the system has been identified as either open system, closed, or isolated system. Now the question is, based on that, if we look into a simple system, if I ask a simple question, is a four-stroke engine an open system or a closed system? Let's think for a minute. What is this about? In fact, this was a question in one of my previous classes. I have been asking this question to the students before talking about the concept of boundary. In a class strength of 56, 30 students' answer was it was an open system. I repeat the question. The question is a four-stroke engine an open system or a closed system? 30 students answered it as open system, and rest of the students answered it as the closed system. The question remains, can a system be both an open as well as closed, or who is correct? The first set of the set of those 30 students who answered it as open system is correct, or is it an actually closed system? You can think about your answers. You can feel, if you think the majority is correct, that shouldn't be, so need not to line yourself with the numbers, because in as far as the number goes, there is more or less an almost an equal number, 30 and 26. Yeah, the answer correct. The answer is a four-stroke engine can either be an open system or a closed system. All the students are correct. How it can be? The question still remains, how a system can both be open or closed, and that's where the concept of boundary comes into picture. If we recollect what we studied in our elemental study of four-stroke diesel engine or four-stroke petrol engine working, there are two openings called as valves, an opening here and two openings, one representing the suction, one representing the exhaust. A system, when one of the valve is open, there is a mass flow in or mass flow out, depending upon whether it is a suction valve or a exhaust valve. So that means in two of the four strokes, namely suction stroke and exhaust stroke, there is no mass interaction, there is only energy interaction. There is heat transfer happening, there is work transfer happening, that means there is energy interaction happening. During the rest of the two strokes, there is mass interaction. So in the mass in and mass out, this is a theoretical representation of an open system, mass in and mass out, which can be an equivalent to what we can say suction stroke and exhaust stroke. During suction stroke and exhaust stroke, we can so conclude going back to, so during suction stroke and exhaust stroke there is a mass interaction, no energy interaction. Going back to our matrix, mass no, energy interaction yes, mass interaction no, so that means it's a closed system. During the rest of the two strokes, namely the expansion stroke and the compression stroke, no mass interaction, only energy interaction, no mass interaction. This remains a closed system. Sorry, there was a small mistake. During the suction and exhaust stroke, in both the strokes there is a mass exchange as well as energy exchange, so that that's an indication of open system. That means the same system during two of the strokes is identified as closed system, and the same system during the suction stroke and exhaust stroke acts as an open system. So hope we have answered the question. The reason being simple and quite indicative. It is the boundary condition that decides. If the boundaries, where we are deciding the boundary. If we consider the boundary excluding this mass interaction, then the same system becomes a closed system. And if we extend the boundary to the cross section of the flow of the mass, then the same system becomes an open system. We can go through these mentioned video links for further clarification on this. A small reflection quiz on what we have learned. A frying pan on a gas stove is a dash system. Options, there are four options: A, B, C and D. Option A, an open system. Option B, a closed system. Option C, either an open system or a closed system depending upon the boundary condition. And D, none of the above. Which is the right answer? That's correct. Option C is the right answer. A frying pan can either be an open system or a closed system depending upon the boundary condition. To make it simple, if the lid is closed, it becomes an open system. It becomes a closed system. If the lid is open, it becomes a open system. You can please submit these two assignments. A small note: you can submit these two assignments before coming to the next class. The question number 1, you can illustrate any two examples. Kindly exclude the two. It's already illustrated in the indicated video, the mentioned video. Illustrate with an example how an open system can be transformed into a closed system, and in both the cases indicate the boundaries. The second assignment is a 4-stroke IC engine an open system or a closed system? How the boundary condition differ during these different strokes, namely suction stroke, compression stroke, expand. You need to make an Excel sheet. You need to make an you need to submit the answer in a tabular form, mentioning on one side the different types of strokes, and on the other side the types, the boundary conditions and the type of the system, and substantiating your answer during each stroke. So that brings that brings an end to this session. To quickly recapitulate, we can take a system. A system can either be open, closed, or isolated depending upon the boundary conditions. If the boundaries are considered such that at least at one part it is open for the mass flow, this becomes an open. If the same is if it is mass tight, it's a fluid tight or the mass tight, it becomes a closed system. And if it is further insulated and no energy transaction as well, it resulting in an isolated system. That means a same system can be an open or closed or an isolated depending upon the boundary conditions. Here are other two examples. If the mass flow is arrested, this becomes an open system is transformed into a closed system. And if the energy transfer, to put it simple, if the heat transfer also arrested, that the same system is transformed into an isolated system. That brings the end. So thank you. In the next class we'll talk about extensive and intensive properties. Thank you.